Okay, hello everyone. My name is Zarif Afarabi and today I will explain the PA and the CS of the operating systems week 3, module 3. And then, yeah, I will just explain it and show the code and stuff. Okay, first of all, the PA, it starts with learning a new, what do you call it, syntax, let's say. It's a fork. uh, so yeah, it's a system that creates child and calling process, and it produces random numbers. Usually there's a parent and the word child, the child itself. Also, wife exited, yeah, this thing called stat, which is a macro for the child process, and returns true and stuff. There's also exec, which is execute command. The best thing I could showcase that when you do an exec, you can have another file that's in the same folder, .c file, and you can exec that file if you already compiled it by putting it in another command. So like, let's say there's like a bunch of code here, we have an exec, and it will exec a different file, uh, and show it in output. There's also other versions of exec like LP, CVP, CV. CVP is for executable system path variable. This is with an else list and stuff like that. Anyway, this is the PA code. It's just a copy from the actual PA. I don't have it open right now. Let's just make it simple. So yeah, we made a PID, which is remember before. This is PID. So PID is for the fork parents and ID. Yeah. Program PID, stuff like that. PID, and then this is just an if situation to fork code. Then we do PID to fork, which just means the PID is the fork. The fork is the PID. And we execute echo. Explain that later. But echo in itself is just echo. It's just showing a quote, basically like doing a printf, so to say, but it's in a different way, just using the execute. And then you have like get ppid. It's just like this: PID equals fork, and we get the ppid, and that's just how you get the numbers. And this is the echo, like waiting the child to finish from before, from the execute. Okay, next case study. This is the output. This is the code. So let's do it for first. So we have two files. I think like 3 later, but we have two files. There's the master and the worker, and the master, first it asks us on the question, it's define, it's to set it up the number of forks, number of workers and stuff, and timeout. We put 15 seconds and the number of this is 5. You just and make it easier. I would have put commands, but too late now. And then the first part is actually writing. This is the full command. This is not the one from during the class. It's the full. So first thing that I've done is write lock, which is, this is for the time log for later here, log file. Yeah, so just open and create, so to say, in the log file text and message and return, and struct local time now, and then print the time hour, which is for this part, right? All these is times, right? So T for Monday, and then the year, the minutes, the seconds, the hour. So that's first for the log file later. Now we get to back to the main code. So the main code, same thing. This is basically like the same thing like the fork. So we do PID to pits, same thing as PID to like here. And then this is for success and failure, because that's about it. We have the worker execution thing for later. And then logs the message, how many like numbers. Yeah, I'm gonna log. This is like a random number, it doesn't matter. And then the random time, because into like a random variable thing. I don't have the questions in it. I cannot open it. I don't have it here. But yeah, we do a random thing for the time and put it on null, and then master program initialize, and we do a for loop, not for loop, and set it up the if condition for the PID to fork with a random 10 plus percentage to 10 plus 1 for A and P, and that will do a printf percentage of this, so it will be this part. This is PID here, and that's will be the output. Next is obviously executing the PID itself, showing the case of PID and then the exec fail or not, stuff like that. Next, we have the exec worker here, which is executing the worker file, which is going to be the code later after this. And then it will show a case during with the list of worker execution. And then just more for loops for the timeouts, wait PID, and then string lock message child PID terminated. This is for the lock file again, this part. And then this is for lock messages, and this is for final summary for the work for the thing here for this. This is actually really longer. The final summary of what's outputted. And that's the magic program. Next is the worker program, which is for the worker execution, and also mixed for this part right here, which is the code itself running, which doesn't really matter, but yeah. Now it's for the worker execution part. Here. So first is obviously connected to the log file.txt and the time itself, same thing. We do a long factorial for long results to 1, which is the n, and that's result to I, and the I is the one from the top, which is PID. Next is invalid arguments, stuff like that, basic. And then we can have the A and B from before to the worker execution, which is received numbers, the sum, and just printing out all the calculation, so to say, from PID. And that's what we got from the output here. So we received numbers with 8 and 2, so the sum is 10, PID 4748, 4745, and then factorial of 8 of not 8 for the first number. That how much that, and also the log file output, which is initialized, child created, what's the PID, computation complete, worker receive arguments, the child data finishes, hopefully maximum program finish. That's it. Thank you.